Good morning, everyone, and welcome to this talk track focused around migrating to Azure. I'm glad you could join us this morning, and I hope you're enjoying the rest of the event. Hopefully you're here because you want to know some more of the good migration practices from the early stages right through to post-migration. We've also put together some hints and tips on building optimization into your culture once you're there, and also how to continually improve your cloud platforms. But before we crack on, just to mention, at the end, there will be a slot where you can ask questions. So please feel free to ask away. So without further ado, let me introduce myself. I'm Chris. I'm an Azure Solutions Specialist at Bytes. I work in our technical pre-sales team. It's my day-to-day to speak to customers about doing all things cloud. I work here delivering sort of transformation projects to build strategies and business cases for cloud. I'm often the first route into our Azure engineering team for organizations that want to do projects with us. It's my job to look at where people or what people are trying to achieve from a business outcomes perspective or a technology perspective and try to map those solutions to them and pull in our highly skilled engineering team to deliver those projects. But I'm sure you've all heard enough about me already. Let's take a look at what we're here to talk about today. Number one, the cloud adoption framework and why you should care. Number two, landing zones. What the hell are they? Why you should be building one. And number three, building an optimization orientated culture and looking at some simple tricks that you can use to always be improving once you're in the cloud. So let's crack on, take a look at the cloud adoption framework. For those of you who don't know the cloud adoption framework, it's a series of white papers, templates, resources that Microsoft have developed over time, alongside some large scale projects that they've done internally to look at how successful projects are run in the cloud and what good cloud adoption looks like. Ultimately, it allows you to do cloud better at whichever stage you're at. The only problem with it is that I think as of June 2021, the cloud adoption framework was over 2,000 pages long. Some of it is going to be relevant for you, some of it's not. And not a lot of organizations or stakeholders within IT get time to read it and understand it and map it to the different business objectives and the different projects that they're trying to be able to deliver on before they migrate. Most people just don't do it at all, which leads to some headaches once they've migrated. As you can imagine, rather long document. What we're really trying to talk about here is, it's really hard to find out what's relevant to you. I will be sipping my tea throughout this as well. So the reason why it's important is one recent fact that I found interesting is that in one Gartner study of cloud adoption, 60% of IT respondents mentioned that the following areas caused major issues. Firstly, organizational misbalance. So that's different people having different expectations of the cloud, and lots of people in your organization might have been sold cloud in a different way. So defining what those expectations are will help you figure out a route to get there, or at least enable you to reset those expectations around maybe not being able to run before you can walk in cloud. For example, finance have probably been told that migrating to the cloud will be cheaper, or marketing have probably been told that they'll be able to do next generation AI and data analytics in a couple of clicks. So what you really need to do is find out what people have been told cloud can do, and then what's actually valuable to the business when trying to build a framework for cloud adoption. Next, we've got the full suite of financial struggles that organizations encounter when trying to make cloud work for them. Again, this comes a little bit down to the expectations versus reality. Many times people will have been sold on the TCO as being less for a cloud migration, and could either put some tangible, intangible benefits into a business case for them. But when you really start adopting the cloud, you might not be able to quantify that. And once workloads are in flight and lights on operations begin, it becomes a bit difficult to stay on top of the original TCO analysis you did once you get some real world costings. I suppose lastly, by no means leastly, is the ever-growing skills gap in the cloud. So sometimes companies that we work with have misaligned expectations around the skills that are existing in their teams. That's not to say that they don't have the skills in their teams, but how available are those skills? Are they tied up doing other projects? How long it will take you to skill up? Everyone knows that by slowly adopting and using the cloud, you'll get your teams using it more, but that process might take a lot longer depending on your organizational standpoint. And lastly, how much help you might need to get, or how much the cost of help from third parties is. So you might need to go out to tender for a managed service provider or some consultancy, or at least some, contractors or something like that, and that's quite expensive. So being able to look at, how to do that and how to do that properly and how to do it that it doesn't sort of disable your business from learning and growing is a really important thing. Ultimately, it's about going in with the right set of expectations, so you don't create more work for yourself further down the line. So here's the cloud adoption framework. And as you can see, there's quite a lot of figuring out to do before you get to a point where you should migrate. If we look at strategy, plan, ready, there are three pillars of the cloud adoption framework that you really need to hammer down before you actually start migrating workloads to the cloud. And I suppose the most important thing in all of this is building a robust strategy. So looking at working across your organizations and asking yourself what's missing. What can you add to your strategy? Speak to stakeholders, third parties, people in your peer network that might have done cloud migrations in a similar way. Figure out what the headaches are, figure out where the battle scars live, and work out other areas to sort of build your strategy around. Then after that, it's all about going into the planning stage. So you should really be looking, if you're planning a cloud migration, at building a digital inventory. And a digital inventory starts with an infrastructure inventory. If you're coming from an on-premise world, if you're coming from a co-location world, what you really need to do is take a list of your infrastructure and start mapping that into what it actually means for your business. So many people will have done, RV tools outputs, Movare assessments, TCO analysis of their infrastructure, but not a lot of people take that a step further and go, how do we map that to applications? How do we then look at what application groups there are based on the common shared infrastructure components there are? What are the interdependencies of them? And then you'll be able to accurately choose what service to move to in the cloud. It won't just be, let's take a list of all these servers that we've got in the outset and migrate all them servers to cloud. It will be, let's take a look at all these workloads and all these applications that we've got running for our business, and how does that look like in cloud? And that will help you with better cloud adoption. But how do you choose that service? So realistically, you need to ask yourself a set of questions. You need to say, is this coming with us? Is there another way of doing things? How does it move? Where does it move? How can we make it better when we move? Does it even make sense to make it better when we move? And I suppose realistically, when doing a kind of application discovery, what you need to look at is the following. So, business criticality. How important is it to your business? If you don't understand that, then you're sort of at a loss really, because you don't know whether it's hugely important to migrate, whether it needs to be migrated in business hours, what the downtime is, and this will help you build your tranche plan. Dependencies, what systems talk to each other, number of interdependencies there are. Can you map applications to infrastructure like we just said, and what shared services there are common amongst everything? So your networking, your monitoring, your storage. Software licensing, so third-party support for cloud services might be an issue. A lot of third-party software vendors are more than happy to support things in an on-prem VMware environment, but do they support something if it migrates to platform as a service, services within Azure? Look at workload utilization over time. So how often is the system being used by people? What kind of people use it? Is it worth migrating if not many people use it? Would it be possible to re-architect it using things like auto-scaling if it's something that grows and shrinks in its usage? And the same for resource utilization. So how much actual resource does that workload consume over a time period? When planning a migration, you don't want to do a like-for-like lift and shift of the current resources that a virtual machine has provisioned in an on-prem world and just migrate it to the same level of resources in the cloud. You want to look at actually what are the peaks and troughs of that? Is it running at maybe 40% or 60% or one of those metrics to be able to actually right size it as you move into the cloud? Obviously, anything that's internally developed will have a lot more flexibility on the migration paths, and therefore it might be a suitable candidate for refactoring or any of the other R's that we see in a 6 R's migration strategy. And then, yeah, what kind of automation, monitoring, or deployment tools are in place that might need to be replaced with cloud services or replicated in the cloud? Maybe you've got certain logging tools, or maybe you've got certain monitoring tools that will need to move into cloud, but maybe there's some more cloud native ways of doing things as a platform in Azure. So here's just an example of what you really need to be doing for each application. And I'm not going to go through the whole list of these kind of things, but these kind of flowcharts are available from Microsoft, and also we deliver them as workshops for customers all the time, where we break down their applications and then we look at each different application and we sort of go, what are we trying to achieve here? What's the different nuance of the workload, and can we recommend a platform as a service for it? Now, what's important is that what we recommend at the start does not necessarily mean it needs to go forever on that platform. Classic example could be a SQL database. A SQL database could have dependencies on the underlying machine, which means that it's not suitable for platform as a service SQL. So you might have identified that to live on a virtual machine in Azure, which is fine. But you should really look at how many dependencies it's actually got on it and what level of effort it would be to move that in the future once you're in Azure. One of the benefits of cloud is you can iterate really quickly, you can fail fast, you can look at replicating a database in a certain different way and looking at all the different kinds of ways of doing things really quickly by utilizing their platform services. If it works, keep it on. If it doesn't work, kill it, doesn't matter. But what you should be using the application analysis at the start of your process to do is identify not just a cloud point one, but a cloud point two, a cloud point three, and look at what kind of effort is involved in evolving that cloud. And that's it for now for the Cloud Adoption Framework. There'll be more sessions on it coming out in the future. But yeah, let us know if you found that useful. Next, we're on to landing zones. So what the hell are they? They're guide rails for good Azure. My opinion is, we will work in IT and someone's given us a process document and they say, this is how we do cloud here. They've said, this is our good way of doing cloud. This is what we want done. This is how we've defined our organization operates in the cloud. However, if you're anything like me, you're not very good at reading instructions. Or if the team that operate your IT are anything like me, they might also not be very good at reading your instructions. So landing zones are all about defining what good cloud looks like and working out how to enforce it whilst allowing for growth. And allowing for growth is the important thing. Let me show you why. So let's ignore Azure for a minute and pretend you were planning a city, not a cloud environment. There are things that you probably want in all areas: roads, sewage, a police service, a way to make addresses and postcodes. And you might want each individual zone to have its unique properties when you build there as well, like wider roads in inner city districts or more security in shopping areas. And hopefully you're starting to get the analogy. So in the IT world, you'll have various different requirements in different parts of your environment. If we map this to Azure, and hopefully in the early stages of that whole strategy and planning phase, you will have mapped them. You'll need to allow the freedom for your developers, or you might need to allow freedom for your developers as much as they want in a dev environment to, try new services and try new things. But you might want to also have stronger checks and balances in production. You might have a separate role-based access control policy for third parties. And so, you might want to build in their own neighborhood in which that is enforced by default. So let's zoom in on that. The landing zone here is the underlying setup that utilizes this area, right? So what that means is this could be an area for your third parties to go and build applications, but they all share a common set of utilities, common set of controls, and a common set of whatever you've defined that they need in that area to mean that whenever someone builds something in that, it automatically inherits it, whether or not they built that from day one or not. So if you've got a third party that says, we need to deliver an application for you, can you give us access to your Azure environment? Absolutely. Here you go. We can enforce a good policy that we know doesn't give you too much freedom, but gives you enough freedom to do your job. And you follow our third-party role-based access control policy, which is fine. The point underlying all of this is you don't have to start by building a whole city to enforce a common set of controls on the whole city. You can just start by building the underlying piping. So in real Azure terms, what this looks like, it's a standardized environment. We'd recommend deploying it via ARM template or Terraform. So that's infrastructure as code, makes it auditable, makes it iterative, makes it really good to actually play with it and sort of start treating your infrastructure development as a code-based project. It's suitable for new and existing environments. So a lot of people often ask me, they say, Chris, we've got what we've thought a landing zone was in place, but we didn't realize what else we can do. Is there any way, should we build a new landing zone, or should we try and sort of clean up our existing landing zone or add to it? Entirely up to you, and it's entirely up to how much change is required to be able to get to a new landing zone. So if you've done a lot of work into a landing zone, you're happy with it, it's running fine, and you're looking at adding stuff, that's absolutely fine. What we'd do is we'd recommend doing that. However, sometimes it's easier to do a greenfield landing zone and then move resources into it as you need it. And I suppose this is all the different kinds of things you need before you deploy any application or workload. So no matter how you segregate it, you need to figure out what is shared and what is nuanced in each of these areas. So if you have a different subscription for each individual, department, or if you have a dev prod UAT third-party subscription, if that's how you've segregated your landing zone, you need to look at your networking. So what kind of networking architecture is needed from each one? What kind of third-party firewalls or cloud native tools you need for IDS, IPS, logging, monitoring, all of that. Identity management goes into the last one a little bit. So how do you want people to access your environment? Active Directory, how are you handling third parties in your Active Directory? How are you having your Active Directory synced back to on-premise? Are you doing that in a hub and spoke networking model? Have you defined that? Governance is what guide rails you need in place. We'll go into this more in a short while, but essentially what you want to do is you want to say, this is what we need to govern, and this is how we enforce it through policy. And then you need to decide where it needs to be enforced, across the board or in specific parts of your landing zone. Security, again, it speaks into the rest of it. So what kind of security tools do you need in place from the get-go? SIEM, IDS, WAF, insert IT acronym here. Everything's got its own nowadays. And then importantly is how you're handling security events. So part of the networking piece is looking at how you segregate your network. Can you lock down subscriptions? Can you lock down virtual networks? Can you lock down application-based rule sets to be able to identify what's been compromised and sandbox them very quickly? And then management. So a lot of people set up their own management subscriptions as part of their landing zone to feed the telemetry into. So they've got a logging subscription and a monitoring subscription. So basically, how can you get the telemetry you need out of your Azure environment to look at different incidents and to be able to operate good Azure? So lastly, one of the last parts of the cloud adoption framework is optimization and improvement. And too many times I've seen it where people will migrate to cloud, leave it, get distracted with something else and go, why on earth does our cloud bill keep getting more and more expensive? And I hate the marketing buzzword cloud is a journey, because that sort of implies that there's a destination that you get to. But that's not always the case. And you really need to look at how you're continually operating in the cloud to get the best cloud that you can. So I suppose to make the most of it, you need to enable more people than you're probably comfortable with to have control on your environment. And I suppose the ability to deploy a resource and consume resources is something that you just allow more people to do than ever before. The problem is those people are rarely ever focused on optimizing those resources and services on your behalf. You're just one person. There's absolutely no way that you can keep on top of everyone continually spinning up and deploying resources. There's absolutely no way you can go through them and optimize them all the time. So I've put together a list of stuff you can try and do to get other people to start caring about some of your headaches. Step one, monitor, report, and collect data. Unless you can monitor things, you can't really prove that things aren't optimized and that there's a waste. And as a baseline, I'd recommend commercial monitoring. So as you're billing and cost management, it will give you a basic insight into your Azure spend. It's free to set up. However, if you want to understand your costs in Azure further, it's recommended to use some third-party tooling to give you greater insight into things like cost per subscription. cost per billing tag, inventory lists, commercial and technical spend reduction, recommendations, loads more of those kind of things. There's many on the market. Bytes ourselves, we make a tool called Quantum, which it does all of those things and more. I'm sure a lot of people in this talk track today might have seen it, but if not, request a demo of it from us because it's a really powerful tool. Secondly, infrastructure monitoring. This is again an area whilst that Azure does have native tools in, as standard, you can only look back at basic logs for about 30 days, depending on the metric. It's crucial that your organization use some of the tooling that's within Azure alongside maybe some third-party infra monitoring tools to take advantage of some deeper analytics. So you could be trying to right-size a solution, right? You might need to look back for more than 30 days on CPU and RAM to see how it's peaked and troughed over, let's say, a 12-month period. You could be retail, you could have a Black Friday, and unless you can look back to last November, you don't know how to right-size things for this November. If this sort of gradually increases month on month, or if it, things like that could really impact your ability to accurately spec a solution. You could also be trying to work out things like if a standard SSD will give you the required amount of IOPS for your application, or if you should upgrade to maybe a premium SSD. Infrastructure monitoring will be able to help you figure that out. But ultimately, what we're trying to say is your infrastructure the right infrastructure for the workloads that it's running? Next, I'd always recommend some application performance monitoring. Now, this sort of ties into the infrastructure monitoring, and I'd always recommend before making any infrastructure changes to do some baselining for how your application is running. Unless you can look at the end state application and how people are using it, you can't work out whether its performance has increased or decreased as a result of an infrastructure change. Now, counter argument to that is change it, see who complains. If no one complains, keep it the same. But you always want to be making sure that people have the best user experience possible, and that I've had it quite often where I've been in front of a IT manager and a team of developers, and we've been looking at something like premium SSDs. I've got a list of premium SSDs from someone's Azure environment, and I've gone, these are not using the amount of IOPS that premium SSDs are using. And a developer will say, oh no, I need the premium SSD for X, Y, or Z reason. And you'll sort of challenge them and you'll go, why have you deployed it with this? And they'll say, my application is written in a certain way. And ultimately what it boils down to is the fact that they've just used the best thing available to them because they A, don't have to pay for it, and B, don't care if it's ever optimized. And lastly, if there was a bottleneck, it will make their application look better at the expense of the IT budget. So you need to be able to actually monitor this and quantify it and say the user experience is not declined by making the change. And just in general, APM tooling is good to have in place. Application performance monitoring. Lastly, less about optimization, but as we're talking about monitoring, from a configuration standpoint, 90% of breaches occur due to misconfiguration. So you really need some security configuration and threat monitoring tooling in place. It's crucial that with security and threat monitoring enabled in Azure, that you monitor it and you get alerts out of it. And the reason why is because it's almost impossible nowadays to continually audit an environment against any given set of standards. So the standards are always changing. And your IT infrastructure is always changing. And without optimizing your security standpoint, you don't know whether you're secure or not. You don't know whether you're misconfigured. So continually improving that security standpoint should be front and center of everybody's mind. And by setting up monitoring on your cloud security posture, you can easily and quickly identify areas for improvement based on different criticality. I know, again, Bytes have a tool that does this. So if you're interested in that, reach out to us. This is indeed the tool that does this. Here's a screenshot of it. One of the key areas for me to build an optimizational culture in your organization is to enable some accountability for your cloud spend. So, as I've mentioned, in the pre-cloud era, the IT department was responsible for everything, from provisioning the infrastructure to the cost of delivering that infrastructure. However, more organizations are adopting the cloud now, and that means more people have been deploying more services than ever before. And that can cause a bit of a cultural problem. It means that teams who are responsible for the public cloud bill at the end of the month are not always the ones who are deploying the resources. The classic example, again, is a development team tasked with building the best products they can will nearly always over-provision their servers, all their disks, and all the other resources in an effort to make the applications perform the best and run the fastest. Once they've done that, though, they'll rarely ever check if they've over-provisioned something once they're rolled out, and they'll rarely ever do it in the name of spend control. So I suppose one of the strongest cultural changes that any IT organization can make if they've got multiple teams responsible for deploying those resources is making them accountable for their cloud spend. And this can be done in a few different ways. A couple of ways that I've seen it being done are, one, setting KPIs and performance-related metrics around avoiding cloud waste, avoiding over-provisioning, and reducing the cloud bill. So this is going back to the monitoring. If you can monitor that things are over-provisioned, if you can monitor things that are being wasted, if you can monitor spend creep on certain resources, then you can actually accurately set their KPIs around that and look at ways of improving it. Another way that I've seen it being done is by aligning a realistic budget for a team or a project, and then remunerating that team in, things like days out, Christmas party beers, any other perks that they might be able to have if they come in under that budget using the amount under that they've done. What's important, though, is that both of those elements, that you keep availability, security, or application and workload performance sort of optimal throughout those cost-saving initiatives. So what you don't want people doing is, when you've got a HA SQL cluster, you don't want them removing one of them and say, look, I've saved half the cost. And that's where, things like your monitoring and your tooling that you set up in the previous slide really play into it, because you can, if someone makes something less secure through doing a cost-saving initiative, you can prove that actually that's weakened your security standpoint, so not actually very initiative at all. And what this will do is it will just help you build an optimization orientated culture. So what that means is your teams will constantly be looking for more things to sort of improve and update. And like I said, by using those monitoring tools, you can sort of give them to your teams and enable them to go out and find further areas for optimization, identify low-hanging fruits, big wins, because now they're being paid on it. It actually makes sense for them to spend some of their time doing it. I suppose lastly, and it speaks to optimization, is trying new things. So try using different workloads. Try deploying different workloads using different services in development. So take a workload that's running, break it down, see if you can run it on PaaS. See if you can run that website or that application server that's running on a virtual machine. See if you can run that on Azure App Service. Take a copy of a database and try and deploy it on Azure Platform as a Service. Then take a copy of the application that uses it. See if it still runs. That's a great way to try a new thing in development in an area where it's not going to make much difference. Try to build new services, though, always using platform as a service tooling. So if you're always used to developing onto virtual machines, try exploring, SQL PaaS, try exploring app service, try looking at even containers as an alternative option for new products. But VMs should always be the last resort, because they're typically the most expensive to run and the most time consuming to manage. Again, look at other metrics that could be improved that aren't necessarily around cost. So could you bolster an application's DR standpoint by trying different HA tools? Could you prove to the business that your environment could sustain various kind of outages? One phrase that's being bandied around quite a lot at the moment is chaos engineering. Could you intentionally make something better and then intentionally turn something off, right, to prove that actually it's resilient if X incident occurs? That'll get your team thinking about how they can do this for the full environment, and sort of building for failure in the future. Next would be to implement a strong governance plan. It's less about your team being optimal, but more about you sort of controlling them and making sure that things will always be optimized in the cloud. So it's really important to build that strong governance plan for that. So when I'm speaking to customers and I'm engaging with organizations doing both technical and commercial optimization reviews, we look at two main reasons why things are non-optimized. So first one is the configuration was wrong, i.e. the workload's been deployed wrong. It's got no tagging, the instance size was too large, it was deployed on a high cost, high performance service when a lesser service would have done, or deploying in the wrong region or something silly like that. And then the second area is people not continually checking as cloud changes. An application that may have been used by everybody might not necessarily be being used by everybody anymore. The workload might have changed, but the services underpinning it might not have. So for both instances, what you should look at doing is implementing a really stringent governance plan to ensure both criteria are mitigated. So to avoid configurations being misaligned, what you can look at doing is implementing things like Azure policy to govern the environment. It will allow people to deploy certain services when the policy is applied. For example, it could prohibit developers deploying premium managed disks in development when standard would have been suitable. But it could also it could also force them to do tasks during deployment, like installing monitoring agents, applying a standard set of tags to them, making it easy to find out sort of what a resource is for, who owns it, and why it was deployed. And that will allow you to look at, are there some people who are repeat offenders? Are there some people who continually sort of over provision resources? But also, if you don't have tagging in place, how are you going to cross charge per department? How are you going to look at what the cost of developing an application has costed you, etc., etc. And I suppose this is Bytes, by the way, from a few years back. This was the whole business a few years back. It's grown significantly since then. But one of the most overlooked elements of Azure optimization is the fact that as infrastructure people, we tend to get focused on the problems that impact our world and not on some of the issues that wider teams could be facing. So trying to engage teams like development to see where the dev bottlenecks might exist, and where some Azure services might help resolve that, like self-serving provisioning, infrastructure as code, Azure DevOps, etc. Or it could be speaking to your security team to see if they've got specific requirements for any products that potentially could be used in Azure or could be replaced with a cheaper to run Azure service. Perhaps marketing have that new data analytics thing at their fingertips that they've been sold, and once you're in the cloud, maybe you could go and use that to help them win new business and build a business case around. Unless you understand some of the sort of key issues that your organization might be facing, and unless you engage with them, your scope for optimization will only ever revolve around the world that you see. And with all of that, all that's left to do is say thank you for attending this session this morning. If you have any questions, please ask away. But if not, I bid you a great day. Enjoy the rest of the event. Thank you very much. I've been Chris College. Have a great day.